something that I experienced tonight that was quite incredible. So you actually have this posted in the nest, um, that thing, the Merkle tree visualization. So I came back home from a gym and I was scrolling my X feed, and I saw that there's a dude who posted a Merkle tree visualizer written in Rust and Go. And the way that the thing works, so he feeds it, like if you open up my post, he feeds it 6 words: Solana, Rust, Anchor, SVM, Merkle trees, and POH. So there's 6 words. So what happens next, his program converts those words to hashes, and those hashes, it's the leaves of a tree, like, so to speak. So if you look at the right side, where it's like 615, 521, 79B, 455, 3D8, 0FD, like those guys, like those pairs, those are the words converted to just the hashes. Like literally the program takes the characters, mixes them up, converts them into hash, and then what happens is those hashes merge into like a parent hash, 925, 492, 8F0. So those are the parent hashes, and as those parent hashes, they merge into like grandparent hashes. Okay, and the grandparent hashes is D87, B09, and so those grandparents merge into this great parent. We call it 1-to-1 1EA, like all the way at the top there on the upper left hand side. Now that is called the Merkle root hash. So the reason to do all that is to understand that should you insert any word into this sort of like a program, you can immediately prove without looking at any other words whether this word, like the word like Rust or Anchor or SVM, belongs to the root hash, Merkle root hash on the very top, 1-to-1 ... 1 EA. Okay, so that's the Merkle trees that are used in all of the blockchains to generate proofs that transactions belong into a block, and then the block's Merkle root hashes are concatenated together to form basically like a trunk of a tree. So it basically everything in the blockchain is a Merkle tree proof. It's kind of like a zero knowledge proof. Zero knowledge means this: if you have a word like Solana and you want to prove that it belongs in the block, you just need to run the Merkle tree calculation against the Merkle tree index, and you immediately get your answer. So that's how you can verify consistency, whether a transaction, in this particular case, this program is using words like Solana, Rust, Anchor, those are words, but if you replace them with transactions, this is how you can prove that transactions actually belong in a blockchain in a particular block at a particular time, so on and so forth. But anyway, this is just the background of what Merkle trees are, and it's not really the point I was going to make. So the guy wrote this thing, and I was reading it and looking at it, and he posted an image. I saved that image to my phone just so that I look at it later. And then I decided to give it to ChatGPT. I literally loaded it into ChatGPT, and I told ChatGPT to write the same program using Python. And so ChatGPT looked at the image, understood the problem, wrote the program, and ran it for me and output what I have on my tweet or my post, where it actually, like, you can see the ChatGPT logo, and then it says, here's the visualized Merkle tree based on the input, blah, blah, blah. It's all like ChatGPT output. So it wrote the program and output the results, showing me that it actually is a Merkle tree. Now, the guy who was the original author of this, he's like, well, yes, it looks good, but but my program was recursive. Like he literally responds to me and says, I have recursion for building the tree. So I went back to ChatGPT and I'm like, okay, write the same program but using recursion. And recursion is a method how the functions are called. It's like a thing in the computer science. Not really, like we don't really care what it is, but the point is it's a different way to style programming and to run like execution. And so what happened next was quite fascinating. ChatGPT already knew that it had a program that did not use recursion. And it started to build the recursive program, and it just kept messing up. Like the output was just not quite the same. And I was just watching at my phone how ChatGPT was literally thinking and saying that, okay, looks like I made a mistake here. I'm not using correct hash functions. I'm using this recursion this way and that way. I should be using it in a different way. Let me try it the other way. And so ChatGPT would then define new programs to generate the input that would match the original input, literally learning from its own mistakes and correcting itself and building a program. So it tried 6 times until it was successful in building the final program that I actually also posted, which is incredible because this is the first time I saw that ChatGPT was literally thinking how to build a program that would match the results against the original program that it came up by itself. So it comes up with the first program, it solves that challenge very quickly, and then I give it a harder challenge. It tries to come up with a second program and it keeps messing up. And it knows it's messing up because the results don't match. And it keeps trying to match the results and say that, okay, I need to do better. And it literally evolved its ability to write a new program on the 6th iteration. It finally figured it out. But there's no doubt in my mind that it actually has learned by giving itself a task to learn, which is incredible. Like I never seen anything like this before. It's like an automated system that literally just figured out how to be better at a task by doing trial and error. And it was like watching a new life form being born. It was incredible. So anyway, I just wanted to share that with you.